Okay, well, I have a rechargeable lithium-ion battery out of a Power Wheels kind of a car thing that used to use lead acid. Now they use lithium-ion. 37 volts, 5200 milliamp hours, 92.4 watt hours. Maximum charge 42 volts. And ad ad tech adpict something. Aid picked. I'm not sure. ALPHARD. So let me zoom out on this thing a little bit. So this is the lithium ion insert, and it does have terminals on this end, and it is noted negative right here and positive right there. So let's just go ahead and lay this thing out. Let me grab a voltmeter here. We'll just set it there. Put it in the volts position, and I get nothing. Nothing. What about on the... No. Charging and discharging. Let's go all the other leads together and see what we get. Oh, 28.4 volts on that one. Huh, interesting. What about on the low impedance mode? Nothing. That's a 3000 ohm load. Absolutely nothing. And back on here, 28 volts. Wow, isn't that something? And 0 volts. Is that shorted together internally? Yes, it is. 0.3 ohms. Well, let's go ahead and so the first thing I'm going to do is the customer did bring me a charger with the unit. Go ahead and zoom in on the, wow, super low contrast writing here. See if we can get any detail. There it is. Output 42.0 volts at 1.5 amps, 63 watts. Made in China. All the best stuff is made in China. Red light means charging. Green light means charge, full, or disconnect. XVE. Okay, interesting. Well, so it has this little jack over here on the side, and it is keyed. So I do have that plugged in. Where is the... There is the indicator light. Get it so you can set up. We can actually see it. Let me get it plugged in here and power on. And it goes right to green. So I'm wondering if it is green now. Let's move this over to get rid of some of the cat hair off of this thing. So you can see the LED is currently green. We'll set this, well, let me zoom out just a tad. Try to move this around so you can see everything. So let's go to volts now and read the terminal voltage. And look at that, I get 33 volts now. It was not doing that previously. What about on the low impedance input? I still get no voltage with just a 3000 ohm load across this thing. So something is going on in this battery pack, I must say. Does it tell me the terminal output? Obviously not, but let's just go ahead, get the meter set up right here once again. I'm going to go in the low impedance mode, and we'll just probe these terminals. And look at that, 42.1 volts. 42.07. What is the third terminal? Probably nothing. Nope, nothing at all. So the charger is working at 42 volts, like it says. So I don't suspect there's going to be an issue with the charger at all. So there are screws. Looks like maybe the clamshell comes off of this thing somehow. Well, let me pop the screws out. I'll be right back. One moment. Well, I got the backside open, and you can certainly see some 18650s in there, most likely. And the front side there is a circuit board being insulated in here multiple times. And it looks like, I'm trying to get down in here where I can actually see what is going on. What'd they do? Did they solder it in place? What the? I can't get this to come out. There's a single wire under here. So some connectors we can probably unplug. Maybe that'll get me a little bit more access, possibly. They glued them down. Thanks. Appreciate that. There we go. It's almost... Where's the focus? There it is. I just don't want this thing making sparks. That must be a temperature sensor. Right there. If I can get it to... It will not unplug. Oh, come on, baby. Oh, the wire's pulled out. Doggone it. So what is the deal? You have to unsolder this, really, to get the battery pack out? Oh, that is unfreaking believable. And there's no way you can actually get this thing to come out because the power plug is larger than the battery pack is. Was it glued in place, really? Well, we got it open enough where we can get to the battery terminals. So let's just go into low impedance mode. And I do see 36.8 volts. Well, that's not too terribly bad. Doggone it. This upsets me that they made it so cheaply that this thing pulls out. What if that was the whole problem? It doesn't look like it was ever crimped in place. It's just bare wires. Wonder if I can repair that. Well, let me see if I can get this plug unplugged. One moment. Well, I did manage to get the plug unplugged for what I believe is the temperature sensor. And I see 8.13 K in one direction. And what do we get in the other direction? Should be the same. 8.14. What about, we'll check the diode range to see if there's anything. 1.842 and 1.842. So this can go on in any direction back to this connector. So I'm going to try to depin this and then resolder the leads to it, and we'll plug them back in and see what happens. Well, I got the temperature sensor resoldered and plugged back in there. Anyhow, it's good. So I thought I'd go ahead and measure each individual cell since I can't get this stupid thing apart. 4.093, 4.095, 4.096, 4.096, 4.094, 4.087, 4.089, 4.087, and 0.012, and 4.088. I'm going to say this is the problem right here. That should be charged. So I'm wondering if I can add a little charge to the cell. Does it have a bad battery management system or just a defective cell? So as these things stand, the negatives are always towards me. Yeah, that thing is charged backwards. So let me go ahead and hook up a power supply and see if I can get a little voltage back into this battery. One moment. Okay, so I've got my power supply set up right here. 4.25 volts, and it's current regulated to 200 milliamps. So let's see if we can put a charge into these batteries at all. Or to this cell, I should say, or multiple cells. There might be two cells. I did go ahead and tack a couple leads on here. And so it is charging at 200 milliamps. Let's see what's going to happen. If this thing decides to make magic smoke, I'll throw it outside quickly. So we'll check back in a few minutes. Well, it's been about a minute and it's up to 1.3 volts. So the cell is taking a charge as far as I can tell. Let me go ahead and disconnect the power supply. Okay, power supply is disconnected and the cell is rapidly discharging. Well, I'm just going to give it some time. We're at 250 milliamps right now. We'll let it charge up and we'll come back in a few moments and see if this thing will retain a charge. Maybe it's just got a bad cell. Who knows? Yeah, there's a bit of a shadow. Let me prop the meter up just a tad. There we go. So I thought just for the fun of it, let's go ahead and plug the charger in while it's charging. And look at that. It's actually trying to put current into the battery now. And I do get a red charge light on this. So if I disconnect the power supply now, it does drop, but it shows that it is still charging. Interesting. Well, once again, let's check back in a few minutes and see where we stand. Well, I thought I would go ahead and hook up the infrared camera and just scan this battery pack and see if I get any kind of a hot spot on here charging that one lone battery. And everything looks pretty good. We're in the 88 degree range, pretty uniform. 89, 88, 88. There is the BMS controller right there, the battery management system, running at 124 degrees. And I don't know if you can see the voltage on the meter right there. If I get the angle right, maybe. Oh, I guess not. Well, we're up to 3.5 volts. And here's the AC adapter sitting over here. We're at 108 degrees peak temperature on it. So I just want to make sure that one battery is not getting super toasty in here at the moment. So it's, like I said, been about 10 minutes. We'll go and check back in a few minutes and see if it's trying to charge this battery. I just wonder if this thing hit 0.0 volts basically, and maybe one cell's got a hair bit of leakage and it discharged below what the BMS could handle right there. Well, I'm going to finish charging the cell completely and then we'll check back probably in about an hour or so. So I do think we have a problem with the battery maintainer circuit or the battery management circuit, because that's all the farther it charges up to, 3.0 volts. That's not enough by any means. So let me go ahead and disconnect this. Stays the same, plug it back in. There we go, 3.1. Light is red. If I can put it here where you can actually see it. 3.16. It should go green any second. There it is, 3.15 volts basically. It thinks that cell is completely charged. There's probably a defective dropping network over here on the battery management system, battery maintainer, thinking that that cell is charged more than it actually is. I'm going to continue to charge this thing on my power supply. I do have it disconnected right now. I will reconnect it. And we'll let this thing charge up 3.8 right now with only 500 milliamps going into it. So we'll check back in a few minutes and see what it has to say. So I don't know if you can see it on the voltmeter or not, but we are currently at 3.933 volts going into this thing. And I just want to measure the temperature once again to make sure there's no like super hot spots. Well, it's kind of looking like in the 83 range. And then the charge controller is pretty cool, 87. I do have the AC power removed at the moment, and I do have my little power supply set at 1.5 amps, and it's already folded back, I don't know if you can see it or not, to 1.39 amps. I have it set to 4.2 volts output, And we're just going to let this thing finish up. As you can tell, the charger is not plugged in right there at all. I don't see any hot spots, so that is very encouraging. Probably another half hour to an hour. It's been going for about an hour and a half right now. I did bump it up to an amp and a half, so should be getting pretty full. All right, well, sorry about the noise, but the house fan's on. It's actually cool in the early AM. So I've got this one battery charged up to 4.23 volts, and I'm anticipating a bit of loss in these leads, maybe 0.03 volts, something like that. So I've got the factory charger right here. Let's go ahead and power that on and see if it goes to red or just immediately to green. And it does, and the voltage stays at 4.23. So I'm going to kill the power supply. I do have my short leads connected here as well. And look at that, it dropped down to 4.0 volts already. Man, I was just hoping it was just a dead cell that they left idle for too long and we could charge it back up. But look at that thing falling. Let's kill the power supply, let the light go out. Then we'll power it back on and see if it tries to charge these things up. Nope, goes right to green. Well, I think the customer needs to purchase a replacement battery at this point because it shouldn't have dropped that much that fast, in my estimation at least. So I'm just going to button this thing back up. I'll put the little insulating paper back in it here and put it back together and give it back to my customer at no charge and just tell him he needs to order a replacement battery. If anybody's got some ideas, let me know. I really would appreciate it. Everyone have a great day. Thanks so much for watching once again. Bye-bye. All right, well, I thought I was done with this battery pack. And I thought to myself, why don't we test the output and make sure it actually puts out some voltage just to make sure it's kind of working. And so I got my meter connected here via the leads. As you can see right here, it's one continuous connection. And as you can see on DC volts, I have nothing. And I thought, well, what about these other terminals on the front of this thing? It's got 4 terminals altogether. So, well, if I go across it with the low impedance mode, look at that, 41 volts. And what is the actual voltage drop? Well, on the high impedance mode, 31 volts. But on the low impedance mode, 3000 ohms, 0.00. So I think I'm just going to put a test clip in there, and then I've got my dummy load here. I'm going to put a couple of 12 ohm, I don't know if you can see them or not, put a couple 12 ohm resistors just to give it a few amps of current, and we'll see what's going to happen. One moment. Okay, hopefully you can see everything okay. Let me scoot this down just a tad where you can see all the resistors there. We'll move this over to there. Okay, that's on volts. We'll go ahead and put it on the high impedance mode for volts. I'm going to go ahead and short the 2 terminals together, and then that falls off. Splendid, absolutely splendid. I don't want those to short, however. It's almost too big. Okay, that is shorted. We've got 41 volts here. 0 amps. Let's put on one 12 ohm resistor. And I've got 3.2 amps pulling down to 40 volts. And that's about as much as I want to try to pull. 6.2 amps. We'll try to do a brief burst of 9 amps. So the battery pack is working at this moment, since I did charge that one dead cell. But still, I think it's compromised. I'm going to give it back to my customer, have him try it at no charge, and just see what he comes up with. Anyhow, just a little addendum that yes, it is actually working. Oh, overload. So what do we got? 11.7 amps. So it can put out some current. What was the voltage at 11.7? 37 volts. Not too terribly bad. So the pack is actually working. Okay, just an addendum, like I said. Everyone, thanks for watching. Have a great day. Bye-bye. Well, I thought I'd go ahead and get the infrared camera out and just take a look at this battery pack and see if there's any warm spots on it, just to make sure one cell is not heating up more than another cell. I do see the battery maintainer system, or BMS, generating 111 degrees, and then the adapter itself, it's got a hot spot of 98 degrees approximately. Everything else is nice and cool. 3.4 volts we're at right now. It's been about 10 minutes on this thing, and I don't see any abnormalities to speak of at this moment. We'll check back in a few minutes.